Hello and welcome to this first lecture, this introduction to the data processing automation course. I'm going to start by talking a bit about the motivation and the structure of the course, and then we'll dive right into Python. So these first two lectures especially, so the two lectures today, will be a bit dense because we are looking at the pieces, how to build Python programs. So I'm going to give you a lot of information, but the idea is not that you memorize everything today. This is the basis for building all the programs we are going to use on the next 6 weeks. So we have time to revisit all these concepts, to play with these elements until you start getting comfortable with this. But today it's just a quick introduction to these elements, and we're going to start by looking at Python objects, variables, and functions, how we can structure code, and I'm going to give you several examples. So first, for a brief overview of the course, the main objective here is that you understand enough of Python programming that you are able to write programs to automate data processing tasks that you have. And also that you have access to useful libraries that you can use for plotting graphs, for computing statistics, for reading data in several formats, and so on. So this is meant as a first contact, as an introduction, to help you then move on, learn what you need. And also the idea is that at the end of this course, you have the necessary knowledge to actually use Python for something that you need to solve. So to solve some of your problems. And what we're going to do is we'll have these lectures on Mondays. So we start at 5 p.m. Then I'm going to give two lectures with a break between. And you can use the Hangout chat if you have questions during the lectures. And then after the lectures, we have this Zoom session where we can have a brief discussion if you have questions, if you have suggestions, and so on. And then we have the tutorials. The tutorials are 1 hour on Wednesdays and Fridays starting at 6 p.m. In the tutorials, we're going to use the Hangout because often many issues are easy to solve even on the chat. You don't need to interrupt what you're doing. But if you have more difficult problems, we can share the screen and I can give you examples, or I can see your code and help you whenever you get stuck. So we're going to use the Hangout for that. This Hangout will serve both for questions during the lectures and for the tutorials. There is, in this course, attendance is mandatory, so this is part of the rules of the doctoral school. And since we are not giving these classes in person, attendance here is measured by the exercises submitted every week. So if because of some problems with your schedule, you cannot attend one lecture on streaming and you have to see it later and so on, that is not a problem. But your attendance on the course will be requires that you submit these exercises every week. So the end of the following Sunday for each week. The exercises are indicated on the PDF where you have the lecture notes and the exercises. So for each week there is a specific exercise that you must submit, and you don't need to submit everything working okay. This is just to let us know that you are keeping up with the course and you are attending the course. Those who need a grade at the end of the course, so this attendance will be just to get the certificate that you attended the course. If you need a grade, then the grade will be computed using 30% of the grade of the exercises and 70% will be the final assignment. I suggest that the final assignment should be somewhere around the middle of January, but we can discuss this depending on what is best for you. You can resubmit all the exercises at the end because the exercises, you submit the exercises for grading and attendance at the end of every week. But if you want to review something, improve something for the final grade, you can resubmit everything at the end. So grading and attendance we can see them as mostly independent things. You need to have the attendance, but you can resubmit the exercise later for grading. All your exercises and submissions for the final assignment and so on, you should send to this address here using the email address you gave to the doctoral school for registration, because I'm going to use those addresses to identify each person that submits the assignments. If you have questions for me, then please write me to my email address, the one where I used to send you the first email with the introduction to the course, because this address here is only for automated processing of submissions. Okay? Okay, for the final assignment, ideally it should be the kind of problem that brought you to this course. So if you have some idea of something that you need to solve with automation, we should try to make this as useful as possible for you, so your final assignment could be part of that problem, or actually solving the problem, depends on the complexity of the problem. So you should think of something that is useful for you. The idea is that you start during the course, and I can give you some help in the beginning, but then you need to do something autonomously so I can grade. This, of course, is for those of you who need to have a grade at the end of the course. If you do not need to have a grade but have some problem that you want to solve, then I can help with whatever you need, because I don't need to grade you, so we don't need to leave anything out of what I help you with. So this will depend on your situation, whether or not you need a grade at the end. So when you submit your final assignment, again, you must submit to this email from the email address you used to register in the course. And in this case, you will send a zip file that has a PDF called report, which has some basic description of what the objective is and how to use your code. You must submit the source code. That must be, I must be able to understand what you did that. So the code must be written in a way that is documented and easy to read. And you must include one script called test that I can use to run your code and to see how things work. You should include a sample of data for whatever you need, but you don't need to include actual data. So if you are working on something that is yet unpublished and you don't want to release the data, you can just generate random data that looks similar to the one you're using just for demonstration purposes. So this can be artificial data. You don't have to send me anything if it's not convenient for you, but it's just to see how the program works. So this would be the format of your final assignment and how to submit it. Okay, so let's go right into the part that matters the most, which is using Python to automate processing tasks. The first question is why we should use Python. Of course, if you came to this course, you already have some idea of what you want, but I want to leave this explicit because these aspects will guide the direction of our course. So if you do manual processing or using spreadsheets or things like that, what you get at the end of your effort is the data processed. What you're aiming at with programming is not to process the data yourself, but to specify the recipe, the process by which the data will be processed. So this is what you produce when you approach these problems with programming instead of using spreadsheets or other kind of manual processing. So when you use spreadsheets, you never fully automate things because usually you have to copy paste from some places, select regions and things like that. So with programming, since everything will be fully automated, and that is the goal, that is one of our goals, it's easy to repeat, to reuse anytime that you need. And because of that, it's also less prone to errors that are hard to identify, these random errors. So if you're doing things manually, you can forget to select some cells or make some kind of mistake when copying and pasting, and this will result in an error that is hard to reproduce because it happened by chance. When you program, there are usually lots of errors, but these are reproducible errors. When you run your program, you get that error, you identify the problem, you correct it, and when you do this several times and test things appropriately, then you should be free of errors and it should work always the same way. If you are processing data yourself, you must keep careful records of how you process the data if you want anyone that comes afterwards to check your work or to reproduce your processing method. When you write code, if you write the code properly, the code itself is the best document for the procedure because it explicitly determines every step that you have to take to process your data. And manual processing doesn't give you reusable or very adaptable tools most of the time. And if you write your code adequately, you can reuse parts of your code easily for other tasks. So these advantages of using programming will be basically the guidelines for how we're going to approach this automation task and how we're going to try to write programs in this course. So basically, we want to automate processing, but this is not a generic programming course. There are several things in programming and software engineering and analysis of requirements and so on that we are simply going to ignore because we are going to assume that what you want to do is to use programming to solve some problem that you already know how it can be solved. So you know what the method is for processing data, you know the algorithms, you may even have practice doing them yourselves by hand, but you want to automate those processes. So we're going to focus on those kinds of problems where you already know how to do things, you just need to know how to tell the computer to do them for you. And those typically are practical problems with very well circumscribed, usually small solutions in code where you can get things working. But we're going to focus on writing code that is easy to read and well documented. Because the idea is that the code that you write is not just for the CPU to run, it's also a record of how you want things to be done, so that anyone can look at your code, and if they are familiar with Python, they understand well what the process it is that you're following. And also, we want to make this as useful as possible, so we're going to always try to break down the tasks into small pieces that we can reuse and adapt to different problems. So if you have similar problems that have some parts in common, your code should be written in a way that you have to change as few as possible parts of the code or adapt as little as possible in order to reuse your code in different problems. So this will be two main concerns that we're going to have. Write code that is easy to read and clear so that we can understand what the code is doing, and also write code that you can reuse and gives you basically a toolbox that you can apply to similar problems. So how are we going to do this? The basic idea is when you're trying to work out some problem with programming, you need to understand the problem, then you need to come up with the algorithm. The algorithm is the series of steps to solve the problem. Then you need to decompose the task, identify smaller parts that are easier to solve, implement each of the smaller parts, bring them all together, and then test, modify, and so forth. So this is for generic problems in programming. We are going to assume that the first parts are already known, because we are going to focus mostly on helping you automate processing tasks that you already know how to solve. So you already know the problem, understand the problem, it's your problem, the one you're working on. You already know what the algorithms are. What you need to do is to tell the computer to work for you. So we're going to focus on this part of implementation, also thinking about how to decompose the task into smaller bits, and especially writing the code, testing the code, improving things, and so work on this later part of the process. So basically what we need to know how to do is how to store things in our program, how our program can remember our data and whatever values we need, how we can do things with those values, how we control what is done and when, and how we can decompose the larger problems into smaller problems and then organize the different solutions and bring everything together. So these are the main elements that we're going to focus here in the beginning. We're going to look at variables where we can store values of different types. We're going to look at operators and functions that Python already provides that we can use to transform the data, to modify the values. We're going to look next week at flow control, how we can decide what is done and when. And then we're going also to look at functions and modules, how we can break down a complex program into simpler bits that then we fit together to do what we want done. Okay, so let's start with the very basic elements in Python, which are objects. So an object, you can think of an object as a tiny program that can work with some values. So it does some processes with some values. For example, consider this integer 2. In Python, this is not only number 2, but it can do some things. It's a very small program that it can tell you how many bits it occupies. It can tell you the conversion to bytes. It can add and subtract and so on from other numbers and so forth. So you can think of everything that you're working with in Python as an object, which is like a tiny program that then you fit together like Lego pieces to build your own program. If you use the dir function, this is a function that Python supplies. If you use a dir function on any object, for example, object 2 here, the constant 2, you can see what everything this object contains, both attributes and methods. So basically attributes are values that the object can remain. For example, the conjugate or the real part of a complex number or things like that. These may be values, or it can have methods. Methods are functions that the object has that can compute something and return some result or produce some effect. For example, you can convert this to a series of bytes using this function here. So usually with objects like number 2, we are not going to worry about these parts because we're going to use it as the number 2 simply. But this is just to illustrate that everything in Python are objects, and we can fit them together by using these functionalities that they have. Some attributes, if you look at the attributes of objects, some attributes start and end with 2 underscores. These are usually special attributes that may be reserved for the system. For example, the absolute value, the sum operator, the conjunction operator, and so on. All of these are used by the system by the interpreter, by Python, in some situations. And then you have other methods that don't have these underscores that we can use freely if we want. Apart from these numeric constants, so for example 12, 23.6 and so on, these are numbers. We have different types of constants. So if you just write a number like this will be an integer. This is one type of value that Python understands. If you have a decimal place, so if you have a period there and then some numbers, or just a period if you want, this will be as a floating point type. So there are some differences in the way that Python stores these values in memory. Remember that the computer only has bits, so zeros and ones, and everything is stored as zeros and ones. In order for the interpreter to know what those zeros and ones mean, it has to keep track of what types of values we are storing. So if you want to use a complex number, for example, you can use this J to indicate the imaginary part, and in this case you have 12 in the real part and 3 in the imaginary part, and you have a complex number. So these are examples of numeric constants that you can create and you can use in Python. You also have other types of values. So I'm going to look at these examples of strings, but of course you can use your constants not only by themselves, but also with operations. For example, addition, multiplication, exponentiation, and so on. So you have some operations that are very widely used. So everyone knows addition, multiplication, exponentiation in Python. You do it by putting two multiplication signs without a space between them. Then you have division. This is regular division. You also have integer division. So this divides two integers and gives you the integer result of the division. So without any fractional part. And you also have this operator, the percentage sign, to get the modules, which is the remainder of the division. So 7 divided by 2 has a remainder of 1, and you can compute it like this. So there are several operations that you can use for numbers, and there are different types of constants that you can use. For example, another very widely used type of value in Python is the string. A string is a set of characters, it can include spaces and so on, that you include between either single quotes at the beginning and end or double quotes. It doesn't matter which one you use, the result is the same, but you must use the same at the beginning and end. And what this tells the interpreter is that the sequence of characters between the quotes is to be taken literally as that sequence of characters and not to be interpreted as meaning something else. So for example, if you type print, which is a function that prints things in the console, and then you give the parentheses, so these parentheses are necessary for functions to give them their arguments and to tell the interpreter that he's to execute the function. And then if you put inside a string like this, hello, you'll see hello echoed in the console, because you told the interpreter to print out this sequence of characters, H-E-L-L-O. If you do it like this, print hello without the quote marks at the beginning and the end, the interpreter will try to understand what you mean by hello. Is this a function? Is this some variable, some name that you defined? And if it's nothing of those things, then it will give you an error. It will say that this name, hello, that you put here is not defined. So basically, when you want to tell the interpreter that this is text, this is not for the interpreter to try to understand what it is, it's just a sequence of characters, then you create a string and you indicate that with either double quotes or single quotes at the beginning and end. These string objects also know how to do things. For example, if you use the dir function on some string, you'll see that there are lots of different things, starts with, strip, title, and so forth. And you can use these methods on the object to return transformed strings based on the original one. For example, if I create the string hello world like this, all in lowercase characters, and I call the title method from this string, this method will return the same string but with the first letter on each word capitalized. If I use the lower method, I convert everything to lowercase. If I use the upper method, I convert everything to uppercase. Replace will find occurrences of this first string and replace it by the second one. For example, replacing all the L's by X's. Swap case will turn uppercase into lower and lower into upper, and so forth. So you see that even this basic piece of text is an object in Python that knows how to do several things, and you can use these methods if you want to do some transformations on the data. So actually you are not changing the string itself. This one is always the same string, but these methods return a new version of the string with the transformation that you want. Strings also can be used in operations. So for example, you can add two strings and it concatenates, this operation concatenates the string. It produces a string that has the two of them stuck together. You can multiply strings by integer values, and this will replicate the string that number of times. So these are examples of things that you can do with these objects. This works because this is not very important in practice, but it may be useful if you understand what's happening under the hood. This works because all these objects have these special methods. For example, this 2_ add 2_ method is a special method that the interpreter uses whenever it finds an addition operation. So since the string has this method and the method implements what to do when adding to other strings, then the object works with this operation and gives us the result that we want. The same for multiplication and so on. So for these simple objects, this will not be anything very sophisticated, but then we'll see when we use the NumPy library that you can do very sophisticated things with matrices and arrays and so on, where you can really define complex operations, and we're going to take advantage of that. So you are not going to define these operations yourself, but you're going to use objects that can use this polymorphism in Python to give us functionalities that are very useful and make some tasks very easy to solve. So all these methods and functions are also objects, but they are special objects. They are executable objects. An executable object contains some kind of recipe to process data, and it is executed when you follow the name by parentheses. For example, if you call from the string hello the replace function like this, so the replace method, Python will tell you that replace is a function. It's a function of string objects. So it's a method of string objects. Methods are functions that belong to objects. You can also call this function help to give you the documentation on any object that you want. So I want help on the replace function that belongs to this hello string. So this will tell you that help is a built-in function, it returns a copy, and so on. So you have a large text here with the help. In all these cases, I'm using the replace name, the name of the function, as a reference to the function itself. But I am not telling Python to execute the function. I'm talking about this function. If I want to execute the function, then I need to add parentheses. Either by also including arguments. For example, replace needs what string to find and what string to replace it with. In this case, L replaced with X. Or if it has no arguments, I just put parentheses there, open and close parentheses. Because this tells Python that I'm not just talking about the function, I want the interpreter to actually execute the function, to do what the function, to perform that recipe that the function has. So if I do it like this, then upper is executed and it returns the string in uppercase. So these are examples of methods. These are examples of functions that you have built-in in Python. For example, the len function gives you the length of any array. So the length of this string is 5. It has 5 characters. Round gives you the integer closest to the number that you give. Int converts something into an integer. For example, this is the string 234, but I'm converting it into the number 234. And this str string does the reverse, so it converts something into a string. So these are examples of how you execute function. You give the name of the function, parentheses, and then any arguments if necessary. If not, then just the parentheses like the upper example here. Okay, so now we know how to use some values and how to do some operations with these values when we have functions available. But we also need to store values that can change. So we need variables in our program. The idea here is that a Python variable is a name, a symbolic reference to an object that is stored in memory. There are rules for these names, and so the variable, the name, must start with a letter or with an underscore, and then can contain letters, underscores, or numbers, but it cannot contain spaces. So these are examples of valid names. var, var1, var underscore 1, underscore var, something like that. Note that in Python, names are case sensitive. So if you start with an uppercase, it's different than if you start with a lowercase or whatever combination you have there. And what happens when we create a variable is that the interpreter will store in memory a reference saying that this name here that we created, for example, by assigning 0 to a, so we create a variable a that stores the value 0, and what the interpreter does is that somewhere in memory it's going to put the value 0 in this memory address. So a memory address is like a drawer in memory where you can put things, and it will store in a table the indication that variable a, so this name a, refers to the contents of this memory address. So here 0 is kept, and here there is a reference saying that it's in that place in memory. Of course, we don't need to know this or this the interpreter takes care. What we know is that we have assigned a value to a. So you can think of variables as bags where you put values or something like that, and you can store them there, and then you can go use them whenever you need. If we create another variable, for example x equals 1, then the interpreter will use another memory address and add to the table that now we have a new name defined, and this refers to the object that is stored in address 102. So this would be the 1 value there, and so on. So basically, to create variables, we use the assignment operator equals, and then we must start with the name that we want for our variable, the assignment operator, and an expression that will give us the value to place in our variables. These values can be of different types. For example, none refers to nothing. You can create the variable and assign it none just to indicate that you have the variable but don't have anything assigned to it yet. You can have integers. For example, in this variable I put the value 505. This is an integer value. In this one I put a floating point, so 9.86 and so on. This is a floating point value. This is a string. This is a string with several lines. So if you start a string with one character of single or double quotes and you terminate it with the same, so that's the rule, your string must fit into a single line. It can be a long line, but it must be a single line. If you need to store text that has several lines, you can start with 3 delimiters. So either 3 single quotes or 3 double quotes, and then you end with the same type of delimiter, but also 3 of them. And in this case, you can have a string that has several lines. Another thing that you can do in Python code, is to add this cardinal symbol, and the interpreter will ignore everything that comes after the cardinal sign in the same line. So this allows you to put in comments. I put a cardinal here and then create variables and choose names. The interpreter will not look at this text, so it will not give some error because it doesn't know what create means or things like that. We can just type comments in our code like this, or at the end of a line you can put the cardinal there and then add comments. Also, when you're trying, I suppose that you already looked at the Spider IDE with that first tutorial that I recommended you look through during the weekend. But if you didn't, then it's easy to find this. You'll see that you have one part of the interface will give you access to the source code file that you write and you save to your hard drive. So this is what I indicate with these yellow boxes. There is another part which is interactive, which is where you type a command and you get the result immediately. I can show you this then in the tutorials, and you'll see this in practice if you didn't do it yet, but I indicate those cases with the gray box. So the gray box is the interactive part where we type something, we enter, and the code is immediately executed, and the yellow boxes are for the source code that we want to keep saved, and we can write a large program and then run everything at once. So here are some examples of what you can do interactively. So in this case I created a variable called 32 and assigned the integer 32 to this variable. And this works okay. If I do enter, there are no complaints. But if I try it this way, if I try 32 equals to this name, then I have an error because I cannot assign values to something that is already a constant. 32 is not the name, it's the actual number 32. So we cannot make 32 refer to something else. It's always 32. On the left side, you must have a valid name for a variable. And on the right side, you must have something the interpreter can understand so it can assign that value to that name. You can use then the variable in the same way as you would use the value that is stored in the variable. So for example, if I store 32 in the name 30_2, I can multiply this by 2 because now this name refers to that object and this will result in 64. So if I store this Python string in this variable called name, then I can use the upper method from the string because this variable is referring to the same object. So it can use this method here, and now I get the string in uppercase. So basically, this is the big use for variables, is that you can have a name, the name is fixed, but the value that is there can depend on whatever you need your program to be doing. So you can write your code using the name, and then the value that's in that name can be whatever the data tells it to be. Python also has a priority of looking up the names. So it's always going to start by names that are closer to the instruction that you give. We're going to see this in functions, the local scope, but the global scope is the set of names that are defined in the same file, in the same source code file or the same session. And then you have the built-in scope, which is the names that Python always has defined by default. So for example, we saw here previously the help function that you can use to obtain help for some object. So if you call help, Python always understands what this means because there is a built-in function called help that Python will use. But if we create a variable called help, and this might happen sometimes, if you create a local variable here in your session, so in this case it's a global variable called help and assigned it a name, if you then try to use the help function, you get an error because now the interpreter cannot find the help function because it will first find the 31 value referred by this name. So if this happens, you can have one name hiding another name. Sometimes this is a good thing because it allows you to isolate parts of your code, but sometimes it's a mistake. You didn't want this to happen. So if this is happening in your source code, you just change the name to fix that. But if this is happening in the session that you're working on, you can use the del function to forget some variable. So if I want to forget the variable help I created here with the number 31, I can use del help. And then when I use help, since this variable no longer exists, Python can find the original help function. So this will not be a problem in your in the source code that you're writing for your programs, but sometimes you may stumble upon this when experimenting with things or running your programs and so on. And if so, remember that you have this del function that can help you forget variables if you want, if you need that. Okay, so let's see an example. We're going to write a program to compute the pH of a solution. So I must apologize for those who are not from chemistry because that's my background and I often go back to chemistry examples. So if you don't remember this kind of high school chemistry, it's not a problem because basically what we have is let's say a solution of benzoic acid. So this is the molecule that breaks down and loses this proton, this hydrogen ion. And so this is the equilibrium in solution that is determining the pH. And this dissociation constant is the product of the concentrations of these two species divided by the concentration of this one. So at the equilibrium, this ratio here will have this value. And now we want to know how much of these protons, of these hydrogen ions, has been released into solution, and we're going to use that for computing the pH. So this is as much as this species here, because the original molecule will break down into these two. So since these two concentrations are the same, this will be the product of the concentration of H plus times itself, because this one is equal. So we have X squared there, and the final concentration of this one is the initial one that we put in solution minus whatever was lost by this dissociation. So this is X that we want to find, which means how much of this was produced in this reaction. So we solve this quadratic equation. We have the formula for solving the quadratic equation. So we have this minus b here, and then plus or minus b squared minus 4a, which is a 1 here, and the c there, and so forth. And then with this, we have the concentration of H plus, and the logarithm minus logarithm base 10 of this concentration is the definition of pH. So we don't know how to compute the logarithm, but we can make this approximation. If you have a limit towards infinity of n multiplied by x raised to 1 over n minus 1, this approximates the natural logarithm of x. So we can use a large n here, say 1000, as this expression, divide by this number to convert between the natural logarithm and base 10, and this gives us an approximation of the logarithm of the concentration. Of course, we have libraries that can do all these sorts of things, but this is just an example to show you several steps and how we're going to implement these. So you're going to create a source code file. You can go to the Spider IDE. You have file new, for example. Then you can save with some extension. For example, ph.py. This .py is the extension for Python source code files. And then you can write your code. So typically you have this indication here to tell the interpreter that this is an UTF-8 text file. This means you can use special characters and so forth. You can have some comments here at the beginning, usually a string with the documentation, and then we write the code. So let's start by creating a variable for the initial concentration. So 0.01 molar, it's the initial concentration of benzoic acid we put in solution. Then we have our constant, our dissociation constant for the acid is this, 6.5 times 10 raised to minus 5. And now we're going to solve here the quadratic equation, but we're only going to look at the positive solution, because the negative solution does not make any sense in chemistry. So we're going to compute x as the positive solution to this equation here. And this is minus Ka plus Ka squared for KaCi and so on. And this is the square root. We can raise to 1/2 to compute the square root, and then we divide by 2. So this tells us the concentration of H plus, and now we approximate the logarithm with that formula, and this is the pH, and we can print the pH. So basically we are creating variables, we are using these expressions, and then printing out the result. And if you run this code with F5, so you have the source code, you can save it, you just press F5 on Spider, and you'll see in the console, so the other window that you have there, this instruction saying that you're running this file that you created, and at the end you see this result. This is the result of this print instruction here. So everything that you did here is not shown on the console. Python just does what you tell it and doesn't make a fuss. But then if you need something to appear, you can use print, and you print out the result. So this was the pH we computed. Now there is a problem here, is that we are just creating a list of instructions, and there is no structure to this code. It's everything in one go, in a long list, and it's difficult to reuse. For example, if you have different concentrations or a different acid or something like that, we have to actually go change the code that we wrote in order to adapt this. It's only useful for this exact problem, and we cannot use parts of the code because it's all done in the same block. So let's see how we can improve this with structured programming. And the idea here is that we can decompose complex code, complex problems, into simpler subproblems using functions. And functions are special objects that can encapsulate a recipe and make it independent from the rest of the program. So this means that once we have one of these little pieces working, we can bring them together with other different pieces and make sure that everything keeps working as well. So you can create a function object in Python using this def instruction to define a function. And what you do is after def, you put the name of the function. And then in parentheses, you must always add the two parentheses, open and close parentheses, but inside you can put the names of the variables that will receive values for the function. For example, suppose that we wanted to create a function to add two values. This is not a very useful function because we can do that already in Python, but it's just to illustrate. We create a function called add. The function will receive two values, and these values will be stored in these local variables. So these a and b are variables that only exist inside the function and will keep the values that anyone has given the function. And now the function has the recipe for adding the numbers. The result of adding two numbers is one number plus the other. And then at the end we have this return statement that tells the interpreter to give the whatever expression we put here, to give it the result of that to the person or whoever called the function. So this is what the function does. It receives two values, it adds two values and puts them in this variable called result. All these variables a, b, and result only exist inside the function, and then it gives back the result to whoever called the function. And this is how we can call the function. After running this, if you run this code, Python will create this object called add in memory that knows how to add these two values. So now we can call the add function and give in parentheses two values that the function will put in a and b, compute everything, and give us the result. So this is the basic idea of how we can decompose problems into smaller subproblems by creating these functions. Now, one important aspect of Python is that all these blocks that begin and end are defined by indentation. So if you write a program like this, Python knows that this part is the definition of the function, but this part is outside the function and it's just a call to the function and putting the result in total. And Python knows this because of this indentation here. So once you write the line for defining the function, you have a colon sign there, and everything that comes afterwards has this indentation. So it's slightly to the right here. If you go back to the original indentation, this means that this is already outside the function. So we're going to look at this with loops, with conditions, with functions, and so on, but this is a basic feature of Python. All these blocks are created by indentation. If there is no return, then the function ends when the recipe ends and it returns a none, so returns nothing. If you have a return, it will end immediately upon finding return. So if you have other things added to the function, for example, like this will not do anything because the interpreter will never reach this line. It will leave the function as soon as it encounters the return statement. The function can be executed by adding those parentheses and the arguments. If you just use the name of the function, then the Python will tell you this is just a function. You have this function defined here, and so with just the name, it's not executed. let's see one important aspect of functions. First is that if you specify arguments for the function, it means that the function must know those values, must be provided with those values. Because in this case, if you don't have both a and b, you cannot compute the sum. So if you call the function with fewer arguments than the ones the function requires, you get an error. So you cannot add 3 without specifying what you'll add 3 to. Also, when you create a function, all the parameters must be variables, because these parameters that you put here are the variables that receive the argument, the values given to the function. So if you want a function that adds 4, for example, you cannot define it like this. The second parameter cannot be a 4, because 4 is not a valid name for a variable. So it cannot receive anything there. So you could write the function like this. It doesn't need to receive the 4. Or if you wanted to add an x, then you would have to put some valid name there. But if you put it like this, this is a mistake. Now, the one important feature of a function is that the variables inside the function live only inside the function. So they have their own, functions have their own local namespace. This means that if you call this function with 3 and 5, a here will have the value 3, b will have the value 5, the function will compute the result and return the result. If you now ask what is the value of a, you get this error. A does not exist outside the function. It only existed while the function was running and has no existence outside the function. Result also does not exist outside the function. It only existed inside the function. This is very important because if you have some variable called a that has a value of 10 here, and you call your function to add 3 and 5, the function has a variable called a, and in this case it will store the value 3. But this variable a inside the function is not the variable a outside the function. So this, after this is done, a is still 10. And this is very important. This is perhaps the most important feature in functions, because this is what allows us to isolate parts of the code and so break down a complex procedure into smaller steps and make sure that when we run the different steps, things don't interfere with each other and don't give us strange errors because of that. Each function lives in its own universe, and the only things that go in and out are controlled by the parameters of the functions and the arguments we give them, and by whatever we put in the return statement. So this way we can use functions to break down large problems into simpler problems. So let's see what we can do with this. First, we need to think about how to decompose the problem. So we have to think about what we want the program to do, how the procedure it is that the program will follow, and then to figure out where to split it into different parts. And each part ideally should be implemented in a way that gives a more general solution, or as more general as is practical. And also it's important to test each part individually before bringing everything together, because if we identify an error while testing each part, we know that the error is there in that small piece. If we bring everything together and find an error, then it may be very difficult to know where the error is. So let's start with our initial script for computing pH and think about decomposition. We have this problem of finding the positive root of the quadratic equation that we can generalize and solve apart from this. Then we have this problem of computing the logarithm, and then finally we bring everything together to compute the pH. So this can be how we break down this problem into different parts. So let's start by writing the functions, the signatures of the function. So the signature is basically this first line. And for the positive root, we have this quadratic equation that has a, b, and c, so we can call it that. The logarithm of x, we can have this argument x, and we return the logarithm. And then when we want to compute the pH, we need the constant, the dissociation constant, and the initial concentration. These strings that we put here are part of the documentation of the function, and we can use them to specify what the function will do, which makes it easier when somebody is reading the code to know what the function will do. But it's also the documentation that the help function returns if someone asks help on any of these functions. So we can actually write very extensive documentation here if you have functions that users will use and you want them to have access to the help on that function. So if I write the positive root like this, so this is a function that has this documentation line here, return the positive root of this quadratic equation. The root is computed using the expression for solving the quadratic equation, but considering only the positive part here, and then we return this value. And if someone asks for help on this function, they get this output, which includes not only the signature of the function, so the name and the argument, but also the text that we put there in the documentation. So this allows us to make it easier to use our functions if you write down what the function does. And then we can test the function. We can see if this equation x squared minus 0x or plus 0x minus 1, what is a positive root, and this one here. So if you use simple examples, you can check if your function is giving the correct result. Okay. So x squared minus 1 should have a root, a positive root as 1, because 1 squared is 1, minus 1, and it's 0. And this, if you have x squared minus 2x and 0, then you should have a positive root at 2, because then you have 2 squared here, minus 2 times x, and it goes down to 0. So you can, this is the basic idea, test each function with some values that you know what the result should be to make sure that the function is giving the correct result. And then we're going to implement the approximation of the logarithm. So logarithm of x, we use that expression, a very large number here and here, and then divide by this conversion factor between the natural logarithm and base 10. And now we can test it. So logarithm of 1 is 0. This is fine. Logarithm of 10 should be 1, but we got 1.001. Okay, this is the approximation that we're using here, but it's close enough for what we need. And now we can bring everything together. So we can create our function to compute pH. We have a multi-line docstring here, so we start with 3 and finish with 3 quote marks. This is for the help. And now we get the positive root of this expression based on the dissociation constant and initial concentration to get the concentration of H plus, and then we return minus the logarithm of H. Okay, so this is, we compute pH and we get the result. We are testing our function. So now we have things implemented in a more flexible way with different functions, and this allows us not only to test each part, so we can actually create a function for tests where we print all the different tests, and this can make it easier to make sure that our program is correctly implemented because we can test each little piece. And also it allows us to reuse our program. So this is just an example of how we can run all these tests. If you create this function, you can then run all the tests just by calling the function. And this makes it easy to test everything, and if you do some changes, you may want to test everything again to make sure you didn't break any functionalities by changing the program. But it also allows us to to easily adapt our program or reuse our program in a new example. So suppose we now want to we compute the pH of 0.01 gram of benzoic acid in a quarter of a liter. So what we could do, we need to compute the pH from mass, but we already know how to compute the pH from the concentration. So we just need to compute the concentration and use the program as it is done already to do the rest of the work. So this is what we're going to do. We're going to compute the concentration and call the rest of the program. So we don't need to decompose anymore. We just add this function, compute pH from mass, where we get the mass of a species that we have in solution, the molar mass of that species so that we can compute the concentration, the volume of the solution, and the dissociation constant. So now we compute the concentration by dividing the mass by the molar mass and the volume, and then return the result of computing the pH using that concentration. This function is part of the program we already built previously. So you see, if you write things down as different functions, then it's easy to extend functionalities, adapt things, and so on. And now we can also include an additional test to our tests function so that all the program can be tested whenever we want. Okay, so just to finish, some hints on coding style, because having code that is readable is important. And one important aspect of this is the names that we use. So names should be descriptive, for example, molar mass, volume, mass, and so on, including the names of functions, except if you already have some conventions that are established. For example, pH, Ka, A, B, and C for the quadratic equation, and so on. So if there is some conventional set of names, we should use those to avoid any confusion. But in general, names of variables should describe what the variable is, and names of functions should describe what the function does. If you want to use multiple words for a name, for example, compute pH mass, you can add underscores to join the different words. This makes it easy to read, and you don't break the rule that you cannot put spaces in names in Python. Also, you should avoid long lines of code. So we could write something like this for the compute pH mass function. We just call compute pH and tell Python to give as the first value the Ka value, and as the second argument this expression here. But this would be harder to read than if we add in another variable, put this name, so that we know that this is actually the initial concentration, and then we call the function. So think about how easy it is to read the code when you're writing it. We also should document the code. So these strings here are useful for knowing what the functions do, and also for help if the user is going to use it. If you want, you can add comments that can warn of some things. For example, when we compute the positive root of this quadratic equation, we are implicitly assuming that this part here is greater than 0. So that this has a real solution. If not, then things could go wrong. So we can put in this warning that we are assuming what we are assuming about the values that we receive. So you have, if you want, you can read the coding style for Python, has lots of these kinds of indications. Okay, so I'm going to finish this first part. We're going to take a short break, and I'd like to let you know that all this information that I gave in this 1 hour and 3 minutes is not for you to memorize or to learn everything right now. This is the basic tool set that we're going to rely on for the next 6 weeks. So basically, you have 6 weeks to learn what I taught in this lecture and the next few lectures. So I'm just telling you what the pieces of the game are, and then as we start playing, things will make more sense, and you'll start to understand and get more comfortable on how to deal with them. So for now, we looked at Python objects, variables, and functions. You're going to practice a lot of this, so you're always going to use variables and functions in everything that we do. So you have a lot of time to gradually familiarize yourselves with these elements. The reason why I am giving this at once in the beginning is that while you are learning to get familiarized with these elements, we can also start looking at specific solutions to practical problems. So we don't have to waste time with toy problems or unrealistic examples we don't have to waste much time in that. We can start maybe next week already dealing with more realistic problems. And so we'll do these two things in parallel. You will learn how to use the tools that you have in the libraries in parallel with learning how to use the basic elements of Python. Okay, so let's take a short break, and at 10 minutes past 6, I will start the second lecture. Okay, see you soon.